Thanks for joining this webinar. Today we're going to talk briefly about digital innovation, particularly focused around problem solving. Now we're going to be talking in this webinar specifically about some key digital focus areas, notably digital reality, the world of IoT, and multidimensional geospatial data visualization and analysis. So we're going to walk through that, and I'm going to paint the picture about how location-based data can help drive solutions. Let's just start with the digital revolution. I've just got a definition at the top which just describes briefly what that is. We're really taking objects, systems, communications and more and transforming them into digital representations as ones and zeros, really putting that data into computers. Now, digital solutions are made up of two core elements. Number one, there's data. And number two, there's software or applications. And as I mentioned, the digital revolution offers new ways to solve problems. This webinar is going to focus on a particular area of this digital revolution, and that's specifically geospatial. Now, geospatial is defined as data that is associated with a particular location. Now, the geospatial revolution we're experiencing is being driven essentially by two core elements. We now are producing a tsunami of new geospatial data. That's two-dimensional data, that's three-dimensional data through LiDAR and other new collection methods, and there's 4D real-time data, and IoT, or the Internet of Things, is a core data generator. So that's number one. We have got a lot of data. Number two is we've got advances in geospatial software, and I'll be showing that in a moment, some examples of how we've moved forward in enabling folks to not only visualize this multidimensional geospatial data, but also to analyze it as well. Now, I'm going to provide in a moment a brief description of three different applications, which I hope help paint the picture about how geospatial data is being used. And I'm going to separate these examples into two-dimensional data, three-dimensional data, and four-dimensional real-time data. To help demonstrate the power of geospatial technology, I'm going to show you a short video which walks through some examples, some use cases of the application of this technology. And again, we're going to talk about this in a multidimensional way. We're going to start with two-dimensional data. In this case, we're looking at a demo in Chattanooga of crash data. You can see we're adding heat maps, we're displaying point data on where collisions are in Chattanooga. We're filtering that data. We've got a time slider at the bottom which shows crashes over time. We can also filter by collision type. 2D data is really good at demonstrating patterns and isolating where particular problems are. We've switched to a 3D demo. In this case, we're looking at floodwater in Houston. What I've just done there is I've added 3D buildings to this application. So we've got floodwater, and we can now see color-coded the most affected buildings by flooding. The red buildings are the most affected by that particular event. And now we switch to another 3D application. This one's around the coronavirus. And we're showing here the confirmed infections across the world. And we're using bar charts in the 3D part of this application just to show where the most affected areas are. A really great way to make that data come to life. Let's look at 4D real-time data. This is a short video showing aircrafts flying over the US. There are thousands of aircrafts moving here. And again, in the sense of IoT, we can now not only track enormous amounts of data and show its movement, but we can also monitor information as well that's coming in real time. Now that we've quickly demonstrated some of the uses of geospatial technology, how we can bring in two-dimensional, three-dimensional, and four-dimensional data to visualize and analyze, let's step a little bit deeper. Let's start talking about digital twins and digital reality. Now, digital twin and digital reality are two confusing terms, and I've tried to define them here. A digital twin is a digital representation of a real-world object or system. That is usually attached to an isolated object. Maybe it's an architect that's designing a building in 3D. One can see the building in isolation and walk inside of the building. We can also create real-world objects of things around us, phones, lamps, etc., etc. Where digital reality becomes different is that digital reality is a spatially enabled digital twin, or an accurately positioned real-world object or system. This is where we're actually modeling the real world. So we can actually see a city, we can interact with a city with a pulse, i.e. a city that's got real-time data coming in. Again, I'm going to show you a very short video and walk through where we actually look at some examples of digital reality. I'm going to share, one shows 2D and 3D data, and the second one shows 3D and 4D or real-time data. I wanted to share two very quick examples of digital reality through a very short video. Let's start with a 2D, 3D perspective. We're going back to our Chattanooga example that we showed earlier. So we're looking at things in 2D, we're filtering data. Now we found an intersection which we think is particularly problematic. Maybe it's number of collisions, maybe it's number of fatalities. Let's provide a new perspective on that intersection. Often engineers will drive out to the intersection, but we can represent that digitally in a digital reality environment. You'll see here we've now got a LiDAR representation of that exact intersection. So we can see problematic areas of its safety we're concerned about. We can also see where collisions have happened, actual collisions. And we overlay GIS data in here as well. So we can start really narrowing down the problem using digital reality. This is a second example. This is showing real-time data. So these are buses in San Francisco. You can see that they're moving. We're tracking them in real time. Now what we've done here is we've added a three-dimensional element to this. So this is digital reality again. So we can now see those buses moving as if we are looking down from an aeroplane at San Francisco. And again, you can see the movement, and we can click on one of those buses and see information about that bus. So we're collecting that information real time from the bus itself. The amazing things that we can do with digital reality when we combine data sets in this way. As we demonstrated, the combination of new technology, new data sources driven by new technology, LiDAR, mesh, and other data collection methods, and new technological advances, we can now, over the web, and the applications the demonstration I just showed were all web applications, we can now share that data with a wide audience. So now we can actually recreate the world around us. We can interact with buildings and vehicles and much, much more. We can bring real-time data in and see, and we can monitor changing environments. We can track the movement of people and vehicles. So a very exciting new world is emerging, a lot of it driven by geospatial technology. And of course, we can link that data to other sources as well, which aren't necessarily geospatial. So a building has a location, what's within the building, we can link into that. So it's really very foundational what we're moving towards. So there's a lot of exciting possibilities here, particularly around problem solving. I wanted to finish with a short discussion on data itself. It's great that we've got new technology that can power solutions as we move forward, but it's very important we get access to data. There's a lot of conversation on open data that's accessible to all. That's certainly very important, but any solution really needs access to other data sources and indeed into GIS systems, proprietary and open source. So it's very important that any system that's built that is looking to solve problems has access to the right data. So just to close, there are an endless array of geospatial solution paths. I hope I've helped to paint that picture a little bit more clearly for you in this presentation. But what's the key question is, what challenging problems are you facing that geospatial technology could help solve? I'd love to know more. Feel free to reach back to me. My contact information is on the screen. Thanks for watching.